This is Unit 7, Lesson 7, Piecewise Linear Functions from Situations. And no, I have no idea what that means. We're going to look at absolute value functions. So if we have y equals the absolute value of x, that's saying that y is equal to negative x and y is equal to x. So on our coordinate plane, everything on this side of the y-axis is negative x. Everything on this side is positive x. In a piecewise linear function, the focus is on the general quantities that the situation is presenting, and the scale is determined based on those quantities. Linear functions represent one relationship between two quantities. Piecewise linear functions represent a combination of linear functions. This is a new marker, and my whiteboard is becoming more and more pink. Let's look at this graph right here. So we've got time in minutes as the independent variable because time's going to continue to move forward no matter what happens. And distance is going to be the dependent variable. This is in miles. So what's happening here is for the first 5 minutes, she's driving to her friend's house. For the next 5 minutes, she's waiting there, and that's why the line goes flat. And for the last 5 minutes, she's finishing driving over to the library. This is an example of a piecewise, whatever they called it, I can't remember, a piecewise because different rules apply at different times. Like we're not progressing anywhere when we're just waiting at the friend's house. This is driving and moving. So this is a piecewise linear function. That's what we call it. There's 3 separate steps in this piecewise function, and it shows that over 15 minutes she traveled 10 miles. I know, I'm a bad graph drawer. Cut me some slack. Because these numbers are close, we're going to use the same scale on the x and y axis. It all goes by steps of 1, but I labeled every 5th mark. The origin of the graph is the starting point because at 0 minutes she's traveled 0 time. And at 0 distance, and it doesn't start until she starts driving. So this middle section where Jocelyn was not moving, she was at her friend's house waiting, is called a step function, which is a type of piecewise function that defines situations that have constant rates between intervals. So between 5 and 10 minutes, she did not increase in distance. This is a step function. So a tutoring company has a set rate of $25 per hour or any portion of an hour for tutoring. This means they'll charge $25 an hour as soon as the hour begins. And a parent wants to know what the cost would be if their son is tutored for 3.5 hourings. So first we need to describe the quantities as well as the relationships between the quantities and the scales that should be used to graph this scenario. So if we have a graph, it's going to be all positive numbers, so we only need one quadrant of the graph. Time is going to be the independent variable, which is going to be x. So time is going to go down here. Okay. Cost is going to be the dependent variable, so it's going to go on the y-axis. Okay. These are the labels for the graph. Okay. So let's say that for time we're going to go by hours, right? So it's going to be 1, 2, 3, 4 for this scenario because they want 3.5, which is going to be right about there. Okay. So this is going to be go by ones, 1, 2, 3, 4. And over here, we're going to go in units of 25 because that's how much they charge per hour. So 25, 50, 75, 100, right? So at 3.5 hours, they're going to charge $100 because they don't do halfway in between the hours. They're paying for 4 hours even though they're only using 3.5. Does that make sense? Now you can also draw a line because at 1 hour it's going to be 25, at 2 hours it's going to be 50, at 3 hours it's going to be 75, and you can connect it and then use this line to figure out how much it's going to be anywhere along the graph. Because they charge by the hour, the graph is actually going to be in a step. So it's going to come chunk, 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 like that. Because it doesn't matter if you're using a partial hour, you're still going to end up paying that $25. So anywhere within this first hour, you're paying 25. Anywhere in this second hour, you're paying 50. So it's going to be a stair step rather than a line. Now we're looking at a snowstorm and how much snow was accumulated during that time. So during the first 3 hours, the snow fell at a constant rate. Then the storm stopped for the next 3 hours. And then it started again, and for the next 4 hours, it fell at a constant rate again. What quantities and scale would you use to label your graph? So go ahead and pause it, figure out what labels you'd put on your graph, and what scale you would use, what quantities you'd use for that graph. Okay, the x-axis is going to be time because time is going to pass at a steady rate no matter what. The y-axis is going to be snowfall because it changes. It's the variable that is affected by what's happening with the weather. Okay, you're going to use units of 1 for the time because 1 hour at a time is passing. And then for the side, you're going to use probably inches depending on where you're living. In my area, in an hour, in a heavy snowfall, you might get an inch in an hour, something like that. You might have to use partial inches if you're in an area that gets less precipitation. But the graph, we don't have actual numbers, but the graph's going to look something like it goes up for a while, it levels off, and then it goes up for a while, just like the graph that we saw before. Okay, Destiny decides to start a clothing line and sell t-shirts. Her goal is to sell 300 t-shirts. Destiny buys the shirts wholesale for $8 per shirt for the first 50 shirts. If she buys 50 t-shirts up to 100 t-shirts, the price is then decreased to $5 per t-shirt. Would a scale increasing in increments of 1 for each axis be reasonable to represent this situation? So do you want 1 and 1 in units for this graph? The answer would be no, because we're dealing with the range for the t-shirt prices is going to be between $8 and $2,000, and the range for the number of shirts is going to be between 1 and 300. Those numbers are not close to each other, and so the scale needs to be different because you're going to end up with all these little teeny tick marks, and it's going to be hard to see what's going on the graph. All right, this is question 1 on the quick check, on the practice, sorry. It says, if you earned up to $120,000 in 2011, you were taxed at a rate of roughly 6% of your income. If you made over $120,000, you were taxed at a flat rate of $8,000. If you were to graph this as a piecewise function to represent the tax for incomes between $0 and $750,000, what quantity would be represented on the y-axis? So the y-axis is always the element, I don't know what you'd call it, that is going to be affected, that's going to be changed. And that's going to be not year, but it's going to be the money that you made, how much money you made. So it's going to be either salary or the amount for the tax. So your salary determines whether or not you're going to be taxed at a higher rate. So the amount of tax is going to increase at a steady rate. That's going to be your x-axis. Your salary determines which type of tax you pay. So I believe that it's going to be your salary for the y-axis. I could be wrong. You know me. Question 1 for the quick check also wants you to determine what the x-axis label is going to be and the scale. Now we're going to start working on graphing piecewise functions. The only difference between graphing them and a like a normal function is that the piecewise functions are made up of pieces or chunks based on different things happening at different times or at different values. Each piece of the function occupies a different part of the domain. An example would be this graph where there are certain pieces. This is a piecewise function because each piece or section only occupies a specific part of the graph. It's important to note that the pieces cannot overlap. Let's look at this function for example. We have f of x is equal to x plus 2 with a domain of x greater than 2. This interval tells us that when evaluating this function, the only valid input values of x are those that are greater than 2. However, we have to include the input value of 2 because it's the boundary point for this function. The values greater than 2 are the ones that need to be calculated past the boundary point. So we're going to create a table, and the values for x are going to be our boundary point, which is 2, and a few values greater than 2, so 3, 4, and 5. To find f of x, we're just going to plug these x values into this formula and solve. Okay, I went ahead and did that. You can pause the video and go over the math if you need to, but our values are now 2, 4, 3, 5, 4, 6, and 5, 7. These are our xy coordinates that can then be graphed, and we can see where that goes. When we graph this, we need to make sure that this point 2, 4 is graphed with an open circle because this is not included. We do not have greater than or equal to, we only have greater than, so this is not included as a correct solution. Here's what our graph is going to look like. Our starting point is an open circle because 2, 4 is not included as a solution. And the line continues on because even though our table stopped, this is any value greater than 2. So it's just going to keep going, and our table stopped, but the correct solutions keep going. For f of x equals x squared plus 2, given the domain of negative 2 is less than x, which is less than or equal to 2, we have this table. We know that our bottom range is going to be negative 2. This is our first value we can have. And our top range is going to be positive 2. This is the table in its entirety. There will not be arrows on our graph going in either direction after this. This one is not included, so it will be an open circle because it is a simple less than sign. This one will be included because it's less than or equal to. Go ahead, pause the video, solve this for f of x, and graph it. Go ahead and pause it, look over it if you need to, figure out what you might have done right or wrong, because you know there's no guarantee that I'm right. But this is what your math and your graph should look like. For the function f of x equals 2x minus 6, given the domain of 3 is less than x is less than or equal to 6, the problem wants to know if this table is correct. Pause the video, figure it out, come back. Okay, they all check out. Go ahead and look at my math if you have any questions. Dude, they tricked me. All of these are correct according to the formula, but it has to be a number that's greater than 3 and less than 6. Oh, negative 6 it says. I wrote it down wrong. I'm so good like that. Yeah, watch me go. Yeah, no, it says 6. So greater than 3 and less than 6. So this one's okay. Let me double check I'm doing this right. This one's okay. This one's okay. This one is not. Greater than 3, less than 6. This one is not. The 3, 4, 5, and 6 are valid input points, it says. So I guess I am confused. I am really confused. I don't know what they mean by 3, 4, 5, and 6. I guess only 6, the x values is what we're looking at. So this one is correct and this one is correct. There is no 4. I don't know why they're saying 4. So I guess this one would be correct and this one would be correct. These ones would not because they don't meet this criteria. Okay, this is an example of a step function. So f of x equals 1 if 0 is less than or equal to x or less than 2. 3 if 2 is less than or equal to x less than 4, 5 if 4 is less than or equal to x less than 6. Okay, so how we graph something like this is similar to what we've done before. Output values will remain constant within the given interval restrictions. So first we need to make an input-output table. Each one of these is going to get its own table because it's its own step. Okay, your output values are going to remain constant. So let's look at the first one. We know from the information it just gave us that the f of x is going to be 1 if x is greater than or equal to 0 and if x is less than 2. So our values for x have to be 0, 1, and it can be 1.99 because it has to be less than 2. And all of our f of x values are going to be 1 because it told us that in the original problem that it gave us. Here's for the next step that it gave us. It said that the f of x is going to be 3 when x is greater than or equal to 2 and less than 4. So our x values are equal to 2 and less than 4. So 2, 3, 3.99. And in the original problem, it provided us with the information that when x is greater than or equal to 4 or less than 6, so 4, 5, and 5.99, then f of x has to be 5. All we did was take the information that was given to us in the problem and translate it into table form. Now that we have all of our tables, we can graph this information. And there is what your graph is going to look like. Because this is a piecewise graph, you have the 3 separate pieces that do not overlap and show the 3 separate functions. This is also an example of a step function because it shows sudden increases from one constant value to another. They're constant because they're straight across, and then there's a sudden increase in between each one. Your favorite media streaming service is offering a new subscription plan. They charge a base fee of $10 up until 10 gigabytes of data streamed. If you watch 10 gigabytes or more, but less than 20 gigabytes of data, you're charged $15 for the month. From 20 until less than 30 gigabytes of data, you're charged $20 for the month. Use this data to create a graph. So the first thing we need to do is take all of this information and translate it into a math form that we can easily deal with. So we create a table with gigabytes on one side and the cost in dollars on the other. I ran out of room, so my table goes and then up here, and then your graph is going to look something like this. Go ahead and pause the video if you need to. You can use the vertical line test to make sure that this passes as a function. And when you hit something like this here at x equals 10, where it passes through this dot and this dot, it still passes the vertical line function test because this dot is included, this dot is not. So it's still passing through only once. Look at my poor pink whiteboard. All right, let's look at this function. We have f of x is equal to 50x if x is greater than or equal to 1 and less than 10, 35x if x is greater than or equal to 10 and less than 15, and 25x if x is greater than or equal to 15. Okay, so create a graph of this function. First, make a table, then create a graph. Pause it, come back. Okay, this is what your table should look like. Whoa, wait a minute. Look at all these weird f of x's. They're not constant. They're not a step function. That's because if you look here, the f of x is 50 times x, 35 times x, 25 times x. So if x is 5, then it's 35 times 5, which is 250. Okay, so here's what your table should look like. Remember that you can use any value for x. They're using nice numbers to graph, like 5s and 2s. You can use whatever numbers you want to use. Yeah. Your graph is going to end up looking something like that. I ran out of room, so it's really inaccurate. But yeah, if you're somewhere in that general area, you're good. For scale, on the x-axis, they went by 2s, so 2, 4, 6, 8, 10, 12. And for the y-axis, they went by 50s. 50, 100, 150, 200. I'm going to have to edit this. Okay, let's try this again. This is a better drawing of this. I actually did this completely wrong because I forgot to draw a point on here. This problem wants to know if this graph is an accurate representation of this set of functions. Pause the video, look at it. This should be relatively easy, so don't get too deep into it and stress yourself out and then come back. So this very first problem says y equals 3 if x is greater than or equal to -2 or x is less than 0. So if we're dealing with y equals 3, there's 2 points here that are set at 3 for y. There's this one and this one, okay? And if you look, both of these are represented by closed circles, but only one should be because we have a greater than or equal to and we have a less than. So this one should be an open circle over here. This one right here should be an open circle, not a closed one. That's where it's wrong. You got a new puppy, you poor thing. You buy a bag of dog food and read the instructions for how much food to give the puppy each day. The instructions state that the amount of food you give depends on how much the puppy weighs. The following piecewise function represents the amount of food per weight. F of x represents the amount of food in cups, and x represents the weight of the puppy in ounces. Here is your piecewise function. And they want to know if the input-output table I'm going to put up here accurately represents the function. They want to know if it's accurate, and then they want you to graph the function. All right, let's look at the table first. So our first one says that f of x is going to be 1/2 of x if x is greater than or equal to 2 and less than 4. So greater than or equal to 2 is going to be 2, 3, all the way up to 4, so 3.99. All of these x values are correct. And then half of x would be 1, 1.5, and then 1.995. So all of these are correct. The first one checks out. For the next one, f of x is just x. If x is greater than or equal to 4 and less than 8. So it will include 4, 6, and it has to stop at 8, so 7.99. And x is just equal to it, so all these numbers are the same. That's all correct. This one is f of x is going to be 2 times x. So x has to be greater than or equal to 8, so it's going to start at 8 and it's going to stop just below 12. So 8, 10, I didn't draw a line, I'm sorry, and 11.99 are all appropriate values for x. And then f of x is going to be twice this. So twice 8 is 16, twice 10 is 20, and twice 11.99 is 23.98. All of the table is correct. Then you need to graph this. So all you're going to do is use your x and y coordinates, draw a graph, and plot it. And your graph is going to look something like that. Okay, so here's a piecewise function. And what they want to know is where would open circles be used and where would closed circles be used. So here we have f of x would be 2x plus 1, and the domain would be x is less than or equal to -1. So this one would be a closed circle because it's less than or equal to, and then it would have a line with no circle on the bottom. So it would be something like something like that. Or it might go the other direction. You don't know. Like it might be like a circle here and then a line going that direction. Okay. So f of x is x squared minus 3x plus 2, and the domain is -x. Well, x is greater than -1 or less than or equal to -2. So this one would be an open circle because it's not included. So at -1, it would be an open circle, and at 2, it would be a closed circle. And for here, f of x is equal to 5, and the domain is x is greater than 2. This would be an open circle because at 2, it's not included. This is question 2 on your practice. It says an online clothing company that does not offer any free items charges a shipping fee of $8 for orders under $25, $4 for orders between $25 and $49.99, and no shipping fee for orders of $50 or more. The following piecewise function shows total costs for a shipment, and I'll write this down on the whiteboard so it's bigger and you can see it. And it wants to know if this graph accurately represents the function. So what you're going to do is you're going to take this and you're going to create a table and you're going to see if these points are all accurate. Okay, so here's our formulas and our domains, and here's our x values. So the first range is x is greater than 0 and less than 25. So greater than 0 means we're going to start at 1. Less than 25 means our top value will be 24.99, and I just picked 15 for the middle value. This one says x is greater than or equal to 25 and less than 50. So our bottom number is 25. Our top number is going to be less than 50, so 49.99. And I put 35 for the middle number. And then the last one is x is greater than or equal to 50. So I just did 50, and then it's going to continue on indefinitely at that point. Now we're going to take these x values, plug them into the f of x formulas, and figure out the f of x values. Okay, here's all the math to figure out f of x. Go ahead and pause this if you need to check. Now our first point that we have is 1 and 9. So it should be like clear down here, and their first point is, so 5, 10, 15, 20. This is every 5. It's somewhere up here in the 7. Well, I guess that could be 9. So that could be 1 and 9. That could be reasonable. 15 and 23 is our next one. So we'd come over here to 15. That could be reasonable. And then we have 24.99 and 32.99. So 24.99 and 32, that could be reasonable. We have 25 and 29. So 25 should be right here. 25 and about 29. That's reasonable. 35 and 39. So 20, 25, 30, 35. And about 39. Yeah, that's reasonable. 49.99 and 53. So 49 and 53. Got 40, 45, 50, 55. So yeah, that's reasonable. And then we've got 50 and 50. So 50 and 50. I would say this is accurate. I would say yes, this is accurate. This is question 3 on the practice. It has this graph, and it says a math club wants to buy t-shirts for its members. The printing company has tiered pricing depending on how many shirts are purchased, with f of x representing the total cost of shirts depending on how many are purchased. And then it gives you a set of functions to use, and it wants to know if this graph is accurate. So pause the video, go do it. I just realized on that last problem I did not check to make sure that the circles were either open or filled as they should be, so you'll want to check that before you put your answer in. And if you need the functions blown up bigger for this problem, this is them. So go ahead and make a table and then graph it. Well, check the graph. We'll check the graph together. Here are the values I picked for x. Our first range is x is greater than or equal to 1, so 1 is our bottom number, and x is less than or equal to 9, so 9 is our top number. I threw 5 in there for the middle. The next one is x is greater than or equal to 10. 10 is our bottom number. X is less than or equal to 19. 19 is our top number. I threw 15 in for the middle. And then we have x is greater than or equal to 20. And that one's not going to have an upper boundary, so we just stop there. Okay, there's all the math to solve these equations, and then we're going to go ahead and compare these points to the graph that it provided for us. So our first point is 1 and 20. So let's see, 1 and let's see, 20, 40, 60, 81. So that could be reasonable. 5 and 100. 5 is going to be about halfway. And 100, yeah, that would work. 9 and 180. Yeah, that's okay. And 10 and 150. Okay. 15 and 225. Okay. 19 and 285. Okay. And 20 and 200. That means it's time for Angie to get on her live lesson. So all of the lines seem to be accurate. Then we need to know if the circles are accurate. So they are all greater than, less than, or equal to, so they should all be open. This, I would say, is accurate. This is number 4, I think. Yes, number 4 on the practice. Looking at this graph, it says Christian covered a total distance of 1.5 miles while exercising. Sometimes he was running, sometimes he was jogging, and sometimes he was resting. During which time interval was Christian resting? So here he was jogging because this is distance. He covered some distance while in 5 minutes. Then he was running because he covered more distance in, it looks, about 7 minutes. And here he was resting because he didn't cover any distance in this time period. So the time period is from 12 to 16. That's the time period when he was resting. This is question 5 on the practice. It says, based on the graph, what will the price be for 6 customers? This is our customers. This is 6. You come right up here. Price will be 90. I like these kinds of questions. These make me feel smart.